Welcome back to All This Math. This is Professor Parker, and here we're doing another installment of Dirt Bike Math. We're doing some work with gas-oil ratios. All right, so let's check this out. So let's first read the word problem. We have a word problem behind us, right? Let's first read it, understand it, right? And then our next step is going to be to, after we understand and comprehend it properly, we're going to create an equation, all right? Because that's the key. You want to create an equation based on the information given. So we gotta employ reading comprehension. So a lot of people think math is all about numbers. Math don't have nothing to do with words or reading. That couldn't be further from the truth. Before you do math, you gotta know how to read. Fundamentally, reading is fundamental, even within mathematics. All right. So we read first, understand the information in the problem, and then we take that information and we create an equation. That's when we start to use mathematical concepts and mathematical rules and in order to create the equation. And then after that, we're going to solve the equation using mathematical concepts and more mathematical rules. We solve the equation, and then we'll have an answer to the original problem. All right. So what this does is gives us some practice on how to read and understand word problems, and then create an equation, and then solve the equation. All right. And if we can do it here, we could do it with any problem that's similar to this, no matter what the content, no matter what the subject, no matter what the problem is talking about. All right. So let's read it. On your two-stroke bike, your gas to oil ratio is 32:1. This means 32:1. Here's the question. How much oil should you put in to your dirt bike off of 2 gallons of gas, right? So if you want to put 2 gallons of gas, how much oil should you also combine with that for your mixture? All right, because you got to put the oil, mix the oil with the gas. Okay. Now, you see, I already have this proportion written up here, and all a proportion is just two ratios, at minimum of 2 ratios set equal to each other. So we got a gas divided by oil equals gas divided by oil. A ratio can be expressed like this, or it could be expressed like this, as a vertical fraction, numerator over top of a denominator. This will be your numerator, this will be your denominator. Numerator, denominator, numerator, denominator. Numerator, denominator. Also, there's different types of ratios. You got part to part ratios and you got part to whole ratios. And I'm going to create some other video content which zeroes in on that. But actually, I think I already have some videos about that. But I'm going to add some more to the channel, to the YouTube channel, that I hope you're already subscribed to. All right. So this is a part to part because it's within the gas tank. Some of your contents will be gasoline and some of your contents will be oil. All right. So this is how much, in terms of a fraction of what's in the gas tank, right? This is how much gas will be in there. This is how much oil will be in there. All right. Now, but we want to figure out, if you put in exactly 2 gallons of gas, exactly how much oil do you need to match up with this amount of gas? All right. So this is what we're going to do. First, we deal with the ratio that we're given, 32:1. We're going to deal with that first. All right. So we're going to replace words with numbers. And that's what a lot of algebra is, just understanding what numbers are going to replace what words. So if we got gas to oil, it's going to look like this. This is our gas, this is our oil. This is our gas, this is our oil, because it says a gas to oil ratio. The word gas is first, this number is first. The word oil is second, this number is second. So that's how you know where the gas number go and where the oil number go. So the first fraction is going to be 32/1. Then you put the equal sign, right? Then the next fraction is going to include the information that we're trying to figure out. We're trying to figure out how much oil. How much oil? How much oil? That's what we're trying to figure out. Always zero in on what you're trying to figure out. We're trying to figure out how much oil. So since we're trying to figure out how much oil, that's in the denominator. So that's going to be our variable. We don't know that. So we call that a variable. You can pick any letter from the alphabet. I try to stay away from certain letters like O, because an O could be confused with a 0. I stay away from T's usually because a T could be confused with a plus sign. I stay away from S's because some of my S's, the way I write, they could be confused with 5 sometimes. So, but typically X is your go-to. All right. Now, how much gas, right, should go right here? 2 gallons, because that's the amount of gas that we're asking about. When we put in 2 gallons of gas, how much oil? 2 gallons of gas, how much oil? 2 gallons of gas, how much oil? All right. Now, we have a proportion set up. Now, there's a specific way to solve a proportion. There's a few different ways, but typically we use the cross product property. Now, what does the cross product property tell us to do? it tells us to multiply the diagonals, right? In an X formation, like Malcolm X, right? Or Omowale Malcolm X, or Haj Malik Al-Shabazz, just like that, right? So we're gonna do 32 times X, all right? That's one diagonal. Then we're gonna do 2 times 1. That's another diagonal. What this does is it helps us to simplify the equation. This proportion right here is also an equation because it has a variable within it and there's an equal sign. Variable, equal sign, variable, equal sign. So that makes this an equation. Actually, if the variable wasn't, it would still be an equation. We just wouldn't have any unknowns. So then that's going to become this, right? It's going to become 32x, because 32 times x is 32x, is equal to, write your equal sign, 2 times 1. 2 times 1 is 2. All right, so now we just simplified the equation. We got rid of the fractions. We got 32x equals 2. That's why I like cross product property, because it helps me to simplify my equations and get rid of my fractions. So I got 32x equals 2. Now I'm going to solve for x. When I solve for x, that means I'm going to isolate x all by itself on one side of the equal sign, right? So that means I'm going to get rid of 32. In order to get x by itself, it means I got to get rid of something. I got to get rid of this number right here, this 32. The question for you is, how do you do that? The way you do it is by doing the opposite operation. 32x means 32 times x. So that means 32x is involved in multiplication already. So the opposite of multiplying is going to be division or dividing. So that means I'm going to divide by 32 on the left-hand side. Now, because this is an equation and I want to keep everything balanced, when I divide by 32 on the left-hand side, I also need to divide by 32 on the right-hand side of the equation. So that's what I'm going to do. 32 divided by 32, these turn into 1s. 1x over 1 is just x. 1x over 1 is just x. So that's plain old x. And then 2 divided by 32 is going to be 1/16. 1/16 is actually, it's a decimal. Is it 0.0625? It might be 0.0625, but I'm going to pull my calculator out just to make sure, because I trust my calculator. 1 divided by 16. And again, yeah, I was right. And the calculator is a tool, not a crutch. Don't let your calculator be a crutch. Let it be a tool, right? Sometimes you do the math mentally, but also, you know what I mean? If I had to, if I didn't have a calculator, I'd bust out some long division. You know, we could do that too. You know, however which way you want it, right? But, so we got x equals 0.0625. Now, this is how many gallons. This is how many gallons, because our units that we're using is gallons, right? So this is how many gallons. And I could have and probably should have included the units within my equation. I neglected to do that, but I could have did that. But just know that this is how many gallons of oil. But that's kind of weird. I don't want to say weird. That's abnormal. Let's use the term like abnormal. That's a little more precise, because an amount of oil would not be represented in with such a small amount, with such a small decimal. 0.0625, right? What you want to do, because it's a small amount, we want to use a more appropriate unit of measurement. So we want to convert this into ounces. Let's convert this into ounces. And if we was dealing with metric system, then maybe I'll do that on another video. Yeah. So on another video, we're going to convert this into milliliters too, right? But for now, I'm going to just give it to you in ounces, all right? Because we're going from gallons to ounces. So in order to go from gallons to ounces, we're going to do another proportion, right? That's what we're going to get into. We're going into another proportion. Now, because we want to go from gallons to ounces, our proportion is going to look like this. Gallons over ounces is equal to gallons over ounces. OZ. Gallons over ounces equals gallons over ounces. Now, you could have did ounces over gallons. With some of my other videos, I did ounces over gallons. But I'm going to show you that it doesn't matter. We still can get the correct answer, because as long as the relationship between the fractions is consistent and is valid. So gallons over ounces equals gallons over ounces. All right, now, I got to know a little bit about unit conversions, though. I got to know up front that there are 128 ounces in 1 gallon. I got to know that up front. So this fraction is going to represent that information. 1 gallon, 128 ounces. 1 gallon, 128 ounces. These are the same thing. 1 gallon, 128 ounces. This represents 1. All right. Now, what we want to know is how many ounces And let's use a different variable. Let's use Y. Let's use Y because we already used X. Let's use Y. So how many ounces? How many ounces? How many ounces? We don't know, so we call that Y. Are in this many gallons. Are in this many gallons. 0.0625. 0.0625. All right. So we got another proportion set up. We know it's 1 gallon in 128 ounces, or 128 ounces in 1 gallon, however you want to look at it. And we want to know how many ounces are in this many gallons, because the relationship between 128 ounces in 1 gallon is the same as a relationship between this amount of ounces and this amount of gallons. All right. So they are consistent. So now we use the cross product property again. We go diagonal. All right. 1 times Y is Y. Write your equal sign. And then we got 128 times 0.0625. 128 times 0.0625. All right, that's what we got. So I'm going back to my calculator to do that multiplication right there. So I'm going to do times 128, and that gives me 8. So Y equals 8. 8 ounces. Y equals 8 ounces. All right, so that's how much oil. That's how much oil I should put into my tank if I put in 2 gallons of gas, based on the manufacturer recommendation of the manufacturer recommended ratio of 32 to 1 for gas to oil. So this is how much oil I should put in there. I should put in 8 ounces if I throw 2 gallons in there, based on that ratio. Now, if you got a different ratio, if you got a newer bike, right, and your ratio is 40 to 1, right, then this number is going to be different. This number is going to be different, but you will use the same math to calculate that. You use the same math to calculate that. And you can use this math to calculate a lot of things, even if you're not even talking about dirt bikes. All right? Because whenever you have a ratio, you can figure out a missing amount based on a given ratio using the same exact process and methods that we used up here. Right? So this ain't limited to just dirt bikes. This is useful in a lot of different scenarios, a lot of different circumstances and situations. You know what I'm saying? So in this situation, with a 32 to 1 ratio of gas to oil, if you throw 2 gallons in there, you need 8 ounces of oil. So make sure you got your oil so you don't ruin your engine. All right. So here's a good guide for you. Another video in our installment on dirt bike math, and use this as a guide. But go ahead, create some practice problems on your own, right? Or deal with some scenarios that if you ride dirt bikes, deal with some scenarios that you encountered on your own in your own real life when you went to the gas station and had to gas up. All right. How much gas did you put in there? How much gas did you want to put in there? How much gas does your tank hold? All right. Do the actual math, because I'm sure a lot of people kind of just eyeball it. A lot of people just kind of go with their instinct and they get intuitive with it. But what math enables you to do is find out the exact numbers. You can find out the exact numbers. All right. That's the beauty of math, because you don't got to guess. You don't got to be like, well, it's not about how you feel. It's not about your feelings. Now, it's math is facts over feelings. This is a fact. Based on this ratio, this amount of gas, you need 8 ounces of oil based on that ratio. All right. So go ahead and get some practice, and I'll catch up with you on the next video. Peace.